Hi, this is Melissa Griswold. I'm doing the final project for IDT 7060. I chose to do my lesson over finding the volume of cylinders, cones, and spheres. This would be done in an 8th grade pre-algebra class. I would do it within the regular classroom setting. I would try to have the students group in partners and then have 2 sets of partners at each table. My district has this unit placed inside of the equations unit because once we get into the application, you're finding for some variables, but it could also be done inside of the geometry unit as well. The goals and the objectives are that students will be able to see the relationship between that a cone is 1/3 the size of a cylinder, and that they will be able to use the formulas and see how that they are related between the area of a circle and the volume of a cylinder and the cone. This goes along with the Common Core standard for 8th grade math geometry, knowing the formulas for volumes of cones, cylinders, and spheres, and be able to use them in real-world and mathematical problems. This is a discovery-based lesson that will also include practice and real-world application once the lesson is done. The first activity that we have is having the students discover what is the relationship between a cylinder and cone. Now, the students are in partners, so we'll each be given a cone and a cylinder of similar sizes that are proportional. They are trying to see that the cone is 1/3 the size of the cylinder. So what they're going to be doing is being given beans, and they actually have to count out how many beans the cylinder will hold and how many beans that the cone will hold. They should be able to see that if you divide the cylinder by the cone, that it should always equal 3, that it would be 1/3 the size of that. The other set of partners at the table will also have a set as well, but those will be a slightly different size, so they can see that this applies to all sizes of cylinders and cones. This should be able to lead into a good discussion so that students can be able to see that relationship, and then we're going to get into later about how that is used inside of the formula itself. So the way that I came up with this is that I wanted the students to be able to see that the area of the circle is used to help find the volume of the cylinder and the cone. Now, we haven't talked about spheres yet. We'll get to that in a minute. But wanted them to be able to see this relationship. So I created this PowerPoint, and all I asked them to see is, what do you notice? And I'm going to put it into the presentation setting so you can see the animation with it as well. So this was what came up on the screen, and I asked the students to have private thinking time so that they're just noticing themselves what they're thinking about, and then afterwards we would discuss it as a class. So this is what it looks like. So I showed it to them the first time where it's all very similar. It's just the rote formulas as it is. And then some of the students were able to come up with their hands and have some thoughts about it, but then I tried it again, this time a little bit differently. So this time I used color coding to try to get the students to see how the pi r squared is consistent in every formula. And then as the circle turns into a cylinder, you're now multiplying it by the height because the height has been added to the 2D surface to change it into a 3D. And then from there, that 1/3 coming into play where we talked about the cylinder and the cone being multiplied onto the end as well. So from there, we should be able to have a pretty good class discussion. And these are some of the things that my students were able to see, that the circles are 2D and that the formula was actually for area, where the cylinders and cones were 3D, and we're finding volume. Every time you're multiplying by another variable and constant, all of the formulas contain pi r squared. That was the main thing that I wanted them to see. And then all of the shapes also involved circles and how that is the root formula as well. From there, I wanted to continue the PowerPoint to really show them that relationship again. So we start off with our circle. It's a 2D flat object. From there, we give the circle some height, and it changes into a cylinder. So the color coding is really useful to where they can see over here there's the circle, and means to multiply, and then the height as well, that the height has been added into the cylinder figure. The cone as well has a circular base. It still has the height because it's still tall, but now it has shrunken down. So you can see where the dotted outline was the cylinder, and so it's 1/3 of, meaning multiply, the formula for the cylinder, so it's in red there. So I try to use the color coordinating to get the students to be able to see those relationships between the formulas and the figures themselves. So one for the more literal student where they prefer the equations, and one for the student that is visual and needs to be able to see an actual picture of it, and hopefully the animation will help that as well. The outcome is that we should be able to have a pretty good discussion about the relationship between the cone and the cylinder, as well as the relationship between the area and the volume formulas as well. From there, I would do some practice actually with the formulas, just some drill where they are getting used to using the formulas, making sure that they're rounding correctly, making sure they're using 3.14 instead of pi, and making sure they're using the correct units, because that is also attending to precision, and that's a mathematical standard as well. At the end of the lesson, the students should be able to complete an exit slip based on the volume of cylinders, cones, and spheres. I'm going to focus on cylinders and cones more, but one of them, I'm going to give them the diameter and see if they need to can see that relationship that I need to divide the diameter by 2 in order to work with the radius, and then solve them, making sure that they have the correct units, rounding, etc. as well. On the second day, I would do some application in the lesson. I would use this almost as a think aloud, but it's a really in-depth problem with multiple steps. So it would be kind of guided with students as well, focusing on finding the important information that the top of the silo has a radius of 8. Talking about what is a hemisphere. We talked about spheres yesterday, so what is that hemisphere and how you would find that. The cylinder has the same radius, and it also has a height of 40. And then now we're trying to see, well, how many trucks would I need if they were an 8 by 5 by 4? How many trucks would I need in order to be completely able to fill the silo? So there we have to find the volume of the hemisphere, the volume of the cylinder, the volume of the truck, length times width times height. But then we would also have to find, make that realization that I'm finding the volume of the silo, so I need to add the hemisphere and the cylinder together. And then I would need to divide that number by the truck size. And so it ended up comes up to about 57 truckloads that they would need. And so I would use this as kind of like a guiding lesson for them, almost a mini lesson, and then have them break into partners again and work on that real world application. Some of the sample problems that I have seen are determining which is a better Coke bottle, a cylinder, a cone, or a sphere. We also have the ice cream cone, how much ice cream could it hold if it were to melt. Containers of popcorn, that they have the same exact volume but they're different sizes, how does that happen, etc. So those are some real world application problems that the students might see to get them to practice those formulas more in depth as well. This is a constructivist theory type based lesson where it's very discovery based. The students are doing the learning themselves. It's not going to be teacher driven, it's going to be student driven. And I think that's very important inside of a math classroom as well. The cognitive theory is also present in the application. It does have drill in it, yes, but on that second day, incorporating the application into the learning, and that's also what the SNEEDER focuses on, is that being able to apply it to a real world setting, not just being able to, plug and chug into a formula. I did use a PowerPoint to help me with that animation as well, and then this is a program that I have called InterWrite that we have at our school, and it's connected with a tablet to where I can annotate, highlight, what's important so that the students can see that as well. So it's very useful, and I absolutely love this program. Inside the PowerPoint, I kind of struggled with how to set this up because I wanted the focus to be on the formulas and not on the background, things like that. So I didn't want it to take it away from it. But then I also wanted to color coordinate it. So I wanted to find some colors that would be aesthetically pleasing, wouldn't clash very much, especially once you get into that animation over here. This looks messy right now because it's, in just the regular presentation or regular mode, but once it goes into the presentation, it does move And so this cleans that up a little bit. And so I chose a white background. I chose to use Cambria because when you're entering in for formulas, they use Cambria Math. So to stay consistent with that, I use Cambria as a font. And then I color coordinated here with the blue figures, the red with the cylinder for the cylinder figure as well, and then the cone with the green cone. But I did think it was important to keep that blue base as a circle apparent in each picture. So this course probably had the most impact on me when it comes to the learning theories, making that aware to me. I was doing them more so with the constructivist theory and the cognitive theory rather than the behavioral. But just bringing those to light and putting a meaning to the name and being more aware of them and how to use them in my classroom. I do consider myself to be pretty fluent in the use of technology, Microsoft Office, Excel, things like that. Not so much as the HTML, so I really did struggle on that one. And I love doing the graphic design stuff. I love designing and things like this, like the PowerPoint, different handouts, graphic organizers, things like that for my kids. But making myself more aware of how to make it aesthetically pleasing with the font, with the white space, things like that as well. And I'm just trying to make it more apparent in my instruction, more transparent as well, so that I'm being aware of it, my students are aware of it, my administration, etc. And I think it has helped me become a better teacher because I'm more aware, so therefore I'm doing more practical implementation and purposeful implementation as well. So that is the end of my instructional design interview for my final project. I hope you enjoyed it. My students seemed to really like this lesson when I did it with them a couple of weeks ago, and they really were able to make meaning of all those different connections that I was trying to highlight. So I considered it to be a successful lesson. There might be some things that I want to change up about it next year. As far as the practice and the real world application goes, I pulled a group in and did like a small group with it because I've had a lot of students absent or just not grasping it as fast as some others, and I know that they struggle in math. So I worked with a group of about 5 students while everybody else worked in pairs, and so that was more structured for them and more guided as well. But I really enjoyed doing this lesson. I really enjoyed doing the animation. That was the first time I had done something like this, and I had the idea in my mind, but I wasn't exactly sure how I was going to make it come to life, and I was really excited with that final product. So I hope you like it. Thank you so much for this course.